So one day, maybe excessive, but I didn't want to. I wanted to record this, and I didn't want to make a video for it. So stream it is. What we're doing is we're converting this renderer, which just crashed because it's so slow, to PixiJS so that we can render bigger and better PCBs. Let's. I guess I can't even preview what I wanted to preview. Maybe I'll try. I'll try harder. If you go to tscircuit.com/seviibar contribution dashboard, we can see sort of a partial version of this. So this one's not being too laggy. There's a little bit of lag, but we're really struggling to render this guy. And it doesn't even have all the LEDs. This has 371 LEDs. Normally, we're only rendering like, I don't know, 40 right here. Yo, what up, Ansh? Go to bed, man. What time is it for you? Jeez. I should just stream in the morning. I think I'm encouraging people to stay up late. I'm caffeinating myself, too. I don't know how you do it. Stay up so late. But anyway, so we're going to try to increase the performance of this by converting it over to Pixie. I think Pixie is probably the best way to do it. I don't know if there's a React PixiJS thing. React Pixie. Okay, so there's a PixiJS thing. I don't even know if we'll use this because I want to be so hyper optimized. And since we're dealing with so many elements, I kind of want to plug into the very native PixiJS system. Anyway, let's get right to it. It's 4 a.m. in India, just working on some issues. Good. Hey, I like to hear it. I'm glad you got that hustle in you. All right, so first things first, let's open up this project. PCB viewer. And we should be able to set up a story that just kind of emulates a pretty hard board to render. And so we should be able to feel the lagginess. So this is a Storybook project. I don't love Storybook anymore. I've mostly switched off it for Cosmos, but this guy's Storybook. We're not going to change it here. So let's see if we can get this running. I'm going to go to localhost 6006. We got some errors. Let's see. Let's try a bun install. Try to get everything up to date. Nice. Okay, cool. So we got a bunch of the PCB viewer that we can play with. So we're going to create a new story that is a really big board. Let's open up the file explorer here. So I already made a director repro 4. I just kind of gave it an arbitrary name. And then we'll say large LED matrix.circuit.json. And then we need to make our stories file. So we'll say repro 4 large LED matrix.stories.tsx. Okay, so we've got our file. And now let's see if we can just copy. Oops. Just copy the content. And then I think we have some formatting set up. I want to make sure it's not mad about our circuit.json. So I'm going to see if I can forbid it from formatting circuit.json. Okay. Okay, so we're importing the JSON. We're going to rename that circuit.json from soup, which is a very old name, to circuit.json. I have only time where I can hustle, nothing to do beside that. Nice. Good to hear that. All right. Well, there's lots of work to do, so sounds good to me. Let's rename this from macropad to repro 4 large LED matrix. I just like those numbers in there. I think it helps to sort things out. That's why I always put them in. Wow, Absy is up too. What are you guys doing? You guys are crazy staying up this late. I came online thinking nobody would be online. Hey, I'm going to sleep. Should I try the circuit.json? I'm doing it right now. I've already done it. I literally just did it. So don't worry about it too much. Yeah. I'm going to try to do the optimization right now. So when you... But your code is still good. What I would do is I would leave open that PR, but I wouldn't merge it. because so basically Absi did exactly what I did right now, except he renders the circuit inside of the web page, which is actually better because you don't have to commit 5 megabytes of JSON. The problem with that approach is that web page rendering is going to kind of mess up the testing. It's going to make it a lot harder to test. We really want to work on just the optimization of the panning, the rendering, etc. We don't want to think about the circuit, the circuit rendering or core. That's a core issue. So we will be working on the core rendering, but in a separate thing. So if that it's probably not going to make sense to anybody, but this thing, it takes forever to load. We don't want to make it take longer is kind of the TLDR. Like, see how quickly, even though it's really laggy now, it didn't crash my browser just to load this because I loaded it directly from JSON. So that's the whole thing. Anyway, this is the board we're going to try to optimize. I'm zooming right now. It's not working, right? If we wait, it'll probably eventually zoom in. There we go. So just so slow. So this is going to be the main thing we work on. And how we're probably going to do this is by converting the canvas rendering. There's a couple ways we could do it. One way is we could defer the canvas rendering, so we could have the transforms operate independent of the canvas rendering. That's a really good approach. And then the other thing we can do is convert it to Pixie. Yeah. The other thing we could do is use our SVG renderer and do a hack with our SVG renderer. I don't know how big Pixie is as a bundle. I already made the title of the stream convert to Pixie, so I feel like I should try it. I don't know what the bundle size of it is, so yeah, we'll have to be a little bit careful. I don't know how big Pixie's bundle is. I'll give it a good go. I'll probably be wrong, you know? I'll probably be wrong and we'll change the approach, but there's so many approaches. Action, there's a saying in startup land, action produces information. So I'm going to try to just try stuff out until we know better. I could like over ideate on this and it would take forever. Pixie.js is how you install this apparently. So Pixie.js. Why can't we also build like tool where people can just import symbol like they do not want to write React code? That already exists. If you don't want to write React code, you can do new resistor. You can already do that. You can go import from TS Circuit Core. You can literally import a resistor. And then you can do new resistor, and you can add that to a circuit. That is all supported. TS Circuit is not only React, but you still have a render process either way. And also, I would recommend using React because if it can force people to use patterns that are a little bit cleaner. React has very good modularization patterns where if it was just scripts, people are going to do crazy stuff, and I don't want that. So React intentionally limits our users from doing things that are too crazy, but you can actually move outside of it. And I would expect a lot of people in production will move outside of it, probably to their own detriment, but they will do it. But, you know, like snippets, the reason why snippets work with each other is the same reason why React components can be imported into your app and usually work. Because React is very, very good at small modules. Drag and drop for schematic symbols for schematic viewer. Like you want to be able to insert symbols from drag and drop and then modify the code. Look, nothing should be done manually in the long run, okay? AI and auto layout should handle everything. It's all, the only things we add for manual editing are stopgap solutions. They're all stopgap solutions until we get a lot better. Good night, Absi. Yeah, thanks for stopping in. Get some sleep. Insertion in particular is a pretty bad idea unless the insertion modifies the code. If you had insertion via manual edits, it would be so limiting. It's not a good idea. Okay, so we have Pixie. I really want to check the bundle size on Pixie. I don't know. Is there an easy way? PixiJS bundle size. This is an old version, though. Let's try 8.6.6. I just want to see if I can. I think this website's been broken a long time, but it still has all the SEO. It says it's pretty small, 9.4 kilobytes. Good night, Ansh. Thanks for stopping in. Cool. Okay. So the PCB viewer basically has a series of layers, and the canvas, canvas elements, and the lowest level is this canvas primitive renderer. This is the one that seems to take the most time. Whenever you drag this thing called the transform, is a matrix that is your coordinate transform. That's basically how the PCB viewer works in a nutshell. So we've got all these layers, dimensions, toolbar, errors, the rat's nest, which is a bunch of wires. That's a standard term. Everything is a layer. And what we want to convert to Pixie is this primitive layer. So where it renders all these all the boxes. So all the boxes are basically primitives. Yeah, primitive can be a line, text, whatever. So we could convert that part to PixiJS, and theoretically that would be very nice. We can test that the canvas primitives layer is the problem, and make sure it's actually a problem with this layer, kind of subjectively, by having it not render everything, just render some of them. And if it's still slow, it means that it's probably one of the other layers. But if it's fast, that means that, okay, this layer is the one causing all the problems. So how this works is whenever the primitives change, or the transform changes, or the selected layer changes, we are redrawing the primitives. We draw them to the canvas. So let's just do, instead of drawing all the primitives, let's just draw, let's say 50, just a couple, so that we can still see our movement. And let's see if that changes anything. Okay. So if we go back to our storybook, we should see a lot less stuff rendered, but I can still hover over it because the hover overlay still exists. And it kind of looks like, it's kind of hard to see, but yeah, it's still really slow. So this actually hints that maybe it's not the canvas that's the issue, which is not what I was expecting. Yeah, that kind of hints that the canvas isn't the issue. So that's not what I was expecting at all. But we can slowly peel back these layers and try to figure out which layer is the issue, because you should be able to just remove these. So it's kind of nice how it's done. That is pretty surprising, though. That makes it possibly our job easier than I thought. Okay, so we've got the edit placement overlay. We've got all these different overlays. This is one problem I don't like about React or any kind of XML nested thing. It's kind of hard to disable these. So I'm gonna bifurcate. I'm gonna do like a binary search basically. I'm gonna come out these four, and we're gonna see if the rendering speed improves. And we're just going to keep doing that, keep eliminating things until it is fast again. I think the primitive order might change. It's still really slow. Okay, let's do edit trace hint overlay. This is a new one. So it could be the problem, but it'd be surprising, but it could be the problem. Okay. I'm dragging. Yeah, I think it's still, yeah, it's still laggy. Okay. This is pretty unexpected. Let's get a little bit aggressive here. Instead of commenting out the code because it's so annoying to track, I'm just going to delete it. There's also the possibility that this thing, there's primitives with interaction metadata, so this could be a big problem. But let's see how this does, how this fares. Still slow. Well, we don't need the primitives without interaction metadata anymore, I think. I don't think it's used for anything anymore. Or maybe it is. Well, we're not using that connectivity map. So let's set that to nothing. Just trying to figure out what's making it slow. Convert element to primitives. Let's take a look. Convert element to primitives. Another thing we could do, just take out, like just make it so this only executes once. Should be fine. Whoops. Oh, yeah. Wow. Okay. So shocking discovery, but that one use memo seems to be causing all the issues. And even more shocking, it's not a big deal at all to remove it. Like it doesn't do anything. The zooming works. A lot of stuff works. So a couple takeaways. One is this memoization is not that good. We could probably spend our time optimizing this one hook. That is very surprising. Okay. So let's go back and just kind of keep confirming our work here. So we're going to make it so it doesn't recalculate. And we're going to render out the entire thing. And yeah, it's pretty smooth. It's definitely tolerable. It could be faster, but you know, it's not a problem. Yeah, it's definitely not a problem. So yeah, I think it's fine. So it's just that recalculation there. Let's take a look where this canvas elements renderer is used. If you try to figure out what's causing props.elements for it to believe that props.elements is constantly changing. So elements. Okay. So it looks like this edit events and PCB elements pre-edit, which is a filter. Okay. So whenever you filter, yeah. So, wow. Okay. Not as hard of a bug as I was thinking. Whenever you filter something, you create a new array. So you have to memoize it, especially in a performance sensitive setting. So in this case, we want to memoize on the circuit JSON, the soup. We might want to make that a single variable. So it looks like circuit.json. This is really tough. I think from a naming situation, this is very problematic. What are all of these things? State elements, circuit.json from children. I think if I reverse this order here, circuit.json is equal soup. It's probably going to break some things. This use rendered circuit function is a little weird, actually. And I don't think I like it anymore. It's pretty cool. It lets you write TS circuit code directly in a web page. But it has so many memoization issues. I've totally fallen out of love with the feature. I think, and it's just not practical, because if you have a large snippet, you probably have imports and stuff like that. I'm going to try not to break too much stuff, though. So we'll say circuit.json equals this, and then we'll look for usage of soup, and we'll just get rid of it, replace it with circuit.json, try to deprecate this soup prop. This hook rule is kind of BS. I think hooks should be very carefully tailored. They actually shouldn't have all their dependencies in it to try to minimize the amount of times they're called. So we're going to remove that. So it falls into the correctness category. And even people like Dan Abramov, they recommend having this on, but I just think it's really hard to optimize without it. It's also really easy to write buggy code, unfortunately. But okay, so this state elements thing I don't understand. State elements seems to be basically just circuit.json. So I think what I want to do is remove this state elements variable and just say circuit.json. And we'll remove it. And then over here, I'll say circuit.json. If it's not defined, it's going to be equal to circuit.json from children or an empty array. And that should at least clarify. We don't need like all these crazy conditions now. And now it's really easy to just say, okay, update on circuit.json here. Because before, that condition was a little bit crazy. Okay, then we're filtering. Yep, that's fine. Apply edit events. Okay. All good. So that memoization might have saved us. So I'm going to revert. We should be able to revert this entire file now, and it should still be fast. We should have just fixed it. As crazy as that may be, we just bought ourselves a lot of optimization. We'll rerun our storybook. This will take a second to start. It's going to open up. And this should be, yeah, look at that. Crazy. So that one memoization fixed our performance issues. And what was happening was it was constantly recomputing every time there was a transform. It was constantly recomputing all the elements. So it was more or less a processing issue and not like related to sort of the rendering of this device. So that's that. Wow. Pretty easy one. That entire diff. No PixiJS conversion. Sorry for the stream title, but I wasn't expecting that. So maybe I guessed wrong what the bottleneck was. Okay. Large LED matrix test. Commit this. That's a huge win though, you know, because everything, smaller circuits are now going to be much faster. So that's pretty cool. There could be problems if that memoization is still triggered too much. So sometimes if you have a really expensive function to run, you want to write maybe a custom memoization to actually check that. Did that edit events array really change? The edit events are the things when you drag anything. We call that an edit event because you edited the circuit in some way. So, it can be smart to do an actual thing. I bet this is still going to get very laggy when you go to drag components. So let's try that out. It's probably going to get really laggy. Yeah. You can see it. It gets very, very laggy because it doesn't know how to compute the delta. It doesn't know how to compute basically like a diff for that object. So it recomputes the entire thing and it ends up being pretty expensive. That's okay though. We can deal with that. We'll fix that later. But for now, we're in a good place. We got a nice performance fix. If we look at our total fix, we did some refactoring, but it's really just this use memo line. That was our entire fix. We got, probably 100x performance gain just with a proper memoization. That's why I love React, baby. All right, so that should publish a new version. This repo is kind of old, so hopefully it publishes automatically. Yeah. All right, cool. That's a pretty good, yo, Anurag, what up? But yeah, baby, I'm back from lunch. I'm ready to go. So that was a big one. That's going to make it so that this renders way quicker on the site. I think the next thing we'll do is some profiling on the core code. If you hit run on this, it takes a really long time to finish. My browser is freezing right now, so it's quite slow. So we're gonna do some profiling, figure out where it's slow, and figure out how to address it. The fun thing about optimization is there's almost always a whale, especially if you haven't been fighting in a while. There's always something that is super, super slow and slows down everything else. In our case, with that last one, we were missing one use memo, and that caused all the problems. For this next thing, I have to keep hitting the page to wait. That's how slow it is to render. There's probably something we're missing and we're just not measuring right now that's causing this thing to hang so friggin' long whenever we hit run. So that'll be the next thing to investigate. Let's see. So with that, I think I will jump right into it. There's one thing on my mind. Wow, it's still going. It's crazy. There we go. All right, finished finally. And we can see our old renderer here. Very, very slow. Very, very slow to zoom in or do anything on this page. But that'll be fixed shortly. That should automatically update in maybe 20 minutes, 30 minutes or so. I'll keep an eye on that. Next thing, we're going to log the events of the renderer. The renderer emits hundreds of thousands of events. So it's perfect for profiling. So we will track those events. Benchmark tests are a little bit difficult. When you're doing benchmark testing, you kind of don't want it to run as part of your regular test suite, and it also doesn't give you a very clean response. When you're looking at benchmarks, they're not like, oh, it's passing or failing most of the time. It's like, oh, we got better, we got worse. So that poses a little bit of a problem. I think we need a little bit of a pattern for, let's see, how can we do this? I'm like, just off the top of my head, I'm thinking benchmark.ts files. And then we output a benchmark results.md file. And we can use that to track how good our benchmarks are doing. This is similar to tracking bundle size. You can also do it on as a comment for each PR and show the deltas. Yeah. I don't really know. Let's see if anybody online has figured this out. So good patterns for benchmark testing. If you guys know anybody watching, if you know a good pattern for sort of tracking benchmarks over time, would love to hear it. The other approach might even be a little bit better. Maybe we can start with this, is to actually just build a GUI. So instead of it running and taking forever, we actually just have a benchmark view inside of here that you can use to inspect the result of the benchmark. And then people kind of get a feel for where the problems are. And that's a little bit easier because with the benchmark files, maybe people don't really know what's going on. Maybe they're really useful to a power user, but they're not perfect for the everyday user. I like that idea. So let's do that instead. So we're not going to do anything in core yet. We are going to just look at events, all those render events that are emitted, and time them. So we'll make a new tab. And we'll call it the benchmark tab. Wow, this file is pretty big. This side menu is going to get really big. All these different views, it's going to get really big. Because we have a, it's not shown here, but we already have assembly. That's a new view. Okay, so we want to make a new tab. So here's the drop-down menu. It's so hard to read code, that's so verbose. Oh, I think my screen isn't showing properly. I just realized. I'm like showing stuff. It's not showing up. Hold on. There we go. I turned it off and back on again. Yeah, let me, before I get into this, let's I'm gonna grab some water. I'm gonna grab some tea. So 2 minutes, BRB. Okay, let's do it. Hello, camera. Track me. Here we go. Has a very mediocre voice control. Okay. So, new tab in the kind of drop down section. This is really confusing as written. Okay, so we got tab content. So the tab content is separated from the drop down. So that's part of why I was confused, I guess. So we've got this drop down menu, and we need to add a new drop down item. Actually, I don't know if I like the word benchmark. It could probably be maybe instead of benchmark, it could be render logs. Let's call it render logs. We'll also definitely want to disable this. So we could say show render logs tab false. We'll set to true for now, the default. But yeah, I don't think that's something you always want to show. Okay, some boring logistics stuff, and now we can do the tabs content. We don't need that boolean. That's dumb. You know, actually, I guess it makes sense. It's a little optimization. Yeah, value render logs, render log. Okay, cool. We're getting there. So it's inheriting this type. So yeah, we'll add render logs. Okay. So that should give us a new tab. We'll do bun run start, which will run Cosmos, which is very similar to Storybook. And we can open up any of these. Run frame basic is a good one. We can go to render logs, and we see we kind of have a sort of an empty page here. So I think step one is just to show all everything, all the logs, all the events, render events emitted. It's going to be very, very big. Yeah, there are literally hundreds of thousands of render events, even for relatively small circuits, because there's this thing, a render pipeline, and every element in your circuit goes through about a 20-stage render pipeline, and then there are multiple events emitted just for that pipeline. And that's to track where things freeze and stuff like that. And also for this benchmarking. So it's maybe too extensive, but it's a nice little feature. So let's see if we can get it to work. So we'll need to pass in, I guess, render logs. And I'm just going to have that defined in a separate file because I think it's going to be a little bit complex. We're going to have to think about it a little bit. I'm going to call it render log, actually. Yeah, let's call it render log instead of render logs. Because there might be, it might not just be a list of logs. We might have some other fancy stuff we can display in it. So let's rename that. All right. going to do this kind of thing. I'm going to have a shrunken left side there, small. Yeah, okay, perfect. Let's define this format, render logs. Okay, maybe this is something that's exported from core. I'm not sure. Yeah, I'm not sure. Okay, so we'll make it an object of any because I'm not really sure what comes out of there. And I'm thinking in the long run, we might have something like phase timing, which will be a record of the strings, how much time that phase took. But I don't actually know if we can do that. Because there's asynchronous sort of stuff that happens. So you have this kind of like background stuff. For example, like if you're trying to get the bill of materials, display the bill of materials or whatever, that might make some calls to APIs or whatever. So you actually can't, it's not even useful really to say how long that phase went for. Because you're not really benchmarking the performance of the stage, just the performance of some external API or the network connection or something like that. To keep this super simple, let's just literally stringify the render log and call it a day. This file is really long. It's kind of hard to manage. Okay. Okay, cool. So we're stringifying the render log. It's like null or empty or something, undefined, so it's not showing anything. But eventually that'll work. We'll keep that up while we develop. So how do we populate the render log now? Let's say render log. Let's define a new one right here. Right when we run that background worker to render the circuit JSON. This is only going to be like 20 lines of code to do it. It's got to be pretty precisely placed for all this to work. I wish I wasn't spending so much time on like the logistics of like benchmarking or something, but somebody's got to do it. It's really tough. And as long as I make the information very visible to others, I think other people can dive in relatively easily. So hopefully it's useful. So we want to get any render event. Man, the types are not helping us here. Let's take a look at core, see what events are emitted by the root circuit. Emit. Looking for keywords here. Listener of event, listener's event. Okay, so on root circuit event name. Okay, so renderable lifecycle any event. Let's do it. And this should be removed. I don't know how I feel about that being there. Somebody added that and then they were like, oh, we don't need it, but they did not clean up. Okay, so we're pushing to the render log. And then we just need to populate it in there. We're doing all these weird touch points, so it's like kind of nonsensical, but it should all just work at some point. I think it should work right now. I think we did it. Did we do it? We should get something. It's saying null. Is that because... So after the rendering, at the very end, we'll say set render log. Or maybe we wait till after it's done rendering? No. Oh, this is a little bit tricky. We actually want to set the render log each time. That's gonna make that's gonna be pretty messy though. We'll do it for now, but that's gonna be pretty messy because that's a lot of set states. Okay. I should set up the default tab for this. All right, let's make a new story. This is a little annoying without a default tab here. So we'll create example. So we're gonna copy example 3. We'll say example 6 render logs dot fixture dot tsx. I can't believe how quickly we were able to get that PCB viewer like working quickly. If we can support boards with 800 plus components, I mean, it's a lot of boards. Knocked down a lot. It only took like 30 minutes too. I was like literally procrastinating doing that bug because I was worried how long it would take. And it executed so quickly. I feel like we're way ahead of schedule now. That rarely happens. Yeah, eventually we're gonna want that, but I don't think it's supported right now. Default. Can you not set the active tab? All right. These props have been found lacking. So we'll say default active tab, and we're going to inherit this from circuit.json preview. Yeah, can I do that? Just removed it. We need to get the props of this. I forget how this works. How do I get the props of a component? To the prop default active tab of circuit.json preview. See if the AI can be a little smarter. No. Use type utilities to avoid duplicating the union. Yeah, there we go. All right, good enough. Parameters is weird. I don't think that's the right way to do it, but good enough. Good enough. So now we should be able to set default active tab, render log, and then we need to make that actually passed through like that. For some reason, it's set to schematic right now. Okay. So if we go to example 6, it now goes to render log by default. For some reason, the render log isn't being populated, though. It's almost as if the event is never being emitted. Okay, so just refreshing the page. And yeah, it doesn't seem to be emitting. This might be an issue with the Circuit web worker, because I believe these events work. I think we have a test for these events. Yeah, let's check out the web worker. So now we're in the web worker code base. So all of this is executed inside the web worker, and we have this .on thing, and it's saying execution context circuit on callback. So that seems pretty solid to me. Okay. Let's just do a quick search to see if there's any tests that actually make sure this event is emitted. So we're going to search for that string. Okay, it doesn't look like we have a test, but we do have this emit here. Seems pretty good to me. I don't see any test for this stuff. I don't get it. There's no tests. Okay, so we'll add a test. We're going to just fill up our context. Ridiculously huge context. I'm probably using $1 on this one query. Write a test that checks that render lifecycle events are emitted. That's going to be big. That's going to be like $1 at least. Might not get it either. When you have that much context, it doesn't usually get things right. But I don't have a smaller version of context to use here. See how it does. I also didn't give it the docs directory. Oh, it's doing terribly. Oof. That's not how we do it. You know, it's not too bad, though. Actually, I don't mind that. It's not too bad. Okay. Render lifecycle events. Yeah, sure. See if it passes. We get a failure. Export. Yeah, so that's a installation failure. Just need to install to fix that. Let's run this test again. Test passes, surprisingly. Render lifecycle events test. render ID. Okay. To have the renderable render lifecycle any event. Yeah. Okay, cool. Man, I love a good test. So it looks like we're not getting any of the renderable lifecycle events. My guess is the reason why this is happening is because of the type here. Yeah. So the any event is a aggregate event type or a group event type. So it's made to it's like an event type that means there are many other events associated with it. So it's kind of a bad type in some ways. I think what we can do. So yeah, it's basically this thing that's causing all the issues. So when we do this emit, even though we're emitting, I'm just guessing, but I think what's happening is even though we're emitting as this event, it doesn't like this type in our payload, and the type is messing up. So we could change this to granular event type. There's probably better names for that, but now something else is failing. Wait a second. Yeah. Okay. Wait. The type should be this. Yeah. Okay. Interesting. Let's just log these events real quick. What's going on? Okay. I don't see any events here. I just see the start and ends. Oh, there they are. Any event. Yeah, see how many events are emitted for the simplest circuit? It's like a absolute flood of data. This seems fine to me. Why is it complaining? End event event.find. No. We don't want to do that. This should be fine. Does this pass if I just comment this thing out? Whoops. Let's get this to work without the aggregate event. So we're not even going to worry about the aggregate events at all. It's saying start event never happened. For phase of phases, we never get, I guess, a start for some event. React subtrees render. Doesn't really make sense though, because doing this is what we did before, type event name. Somehow it passes when you do this. That doesn't really make any sense. I'm going to recall the start or end. It's incredibly confusing for it to be called an event type. Start or end. Okay, we're still passing. Cool cup for tea. This is just your standard glass teacup. Standard stuff. Where are you at where you can't get a nice glass teacup? Glass doesn't hold... it doesn't have like as many crevices or whatever for stuff to fall into. I think I'm going to do event payload here. I think that's a little bit more clear. Can I leave a message? To be truthy. And then am I allowed to leave a message? I'm not allowed to leave a message. This is kind of dumb, that part of the test. Let's not do anything with render ID. Start event, end event, to be truthy. I have the same double class teacup, but it's 400 milliliters, so it's bigger. I don't know how big this is. 400 milliliters sounds pretty big. Yeah, I got some hot water. I got a big tea kettle. I'm in my happy place. Optimizing. Not optimizing yet. Figuring out what the hell the problem is. Let's try using console.table here. Maybe clarify it a little bit. Oh, now we have no events. How have I done this? For some reason, only this emit works. I think it's because we're only listening to this, so you can only catch things that you're listening on. Otherwise, the emit just does nothing, which is actually good for performance. Let's try doing this. Let's go do this, and then we're going to say granular event type. I don't know. I'm trying to do some weird patterns here, but they might be too risky. Also, all this any casting stuff is causing issues. Okay. All right. I think I understand what the issue is. I also think that our original solution of emitting the granular event type as the type is probably fine. I might regret it later, but I don't know. We'll see. I don't even know if people will use these events beyond this benchmark. So those are all the render events. You can see every component and each phase of the render cycle it goes through. And the circuit is only one resistor. So this is for one resistor, one 0402 resistor. Those are all the events that are emitted. There are 323 events for a single resistor. Because like the resistor creates subparts which each have their own render cycles. So yeah, there's a lot emitted. Most of them don't do anything for their render phase, but yeah. There's 300 for a component that basic. There's going to be hundreds of thousands. The benchmark view is going to be really slow. Luckily, I think they're pretty efficient, the edit events. So I don't know if I really changed anything in this implementation. I did like some refactoring, but I think if I were to revert this, let's stash our changes to this file. I'm pretty sure the test will pass. Oh, it doesn't want to stash. Hold on. Get reset. Oh, I don't know. It doesn't want to stash. Oh, I forget how to stash a single file. Stash just a single file, yes. Get stash dash dash. Okay. So what we'll do, we're going to stash the changes to this file, see if it passes. And then we'll stash pop if we like our refactor. And I think I do, because some of the stuff, like this being event type, is just really, really bad naming. Really, really poor naming. Super ambiguous. So let's run our test. Test still passes. So we're not actually fixing anything. We're improving the naming, but we're not fixing anything. Disappointing. So we'll say fix or add test, and then we're going to do get stash pop, improve, let's say refactor emit function to avoid ambiguity. It's good that we have a test now. Okay. I'm going to merge this in just because now I understand the code that's been written. But we have a big problem because we're not seeing any of those edit events get propagated up. We're just going to have to go through each dependency and try to write a test in each one until we've isolated where in the stack we're getting issues. So here's a test. Yeah, all right, so we'll create new test, example 5, event recording. Oh, you know what else we could improve on this PR? Just realized we don't export the event types right now. So I wonder if that could be a way to improve it. I'm not going to worry about it. It's fine. I just did, I think, a 30-minute yoga session. I'm trying to do something every day. But yoga is always, you feel pretty good after, I've noticed. I always feel pretty good after yoga. My back is like, very happy. Also, I was reading YouTube comments late last night. This is maybe what triggered me to do yoga. I was reading YouTube comments and they were all like, all these massage therapists were talking about how their clients who did yoga, they didn't have any knots on their back. So, all right. If it works, it works. Event, console.log events. Let's not do that. Push the events into an array. This code is garbage land. How can I improve this? README example. Oh, yes, that's much better. That's much simpler. Let's do that instead. Nice. I'm using a saddle chair so I can sit backwards if I want to. Straighten my back a little. Not that it hurts. As I said, I did yoga, so no back pain here for now. Okay. Not the best test because it does some render events. We can simplify this. We'll just do a resistor, no imports. Run a little faster. Okay. Okay, so we're gonna render, get the circuit JSON. We're not gonna do any test against it. Yeah, it's fine. All right. We'll expect some events to be emitted. Okay, so it's not working. Great. We have to put in the right event here. So, assuming this is the right event, could really improve the types here too. We'll say that we'll pretend that's the only event you can listen to. Okay, run the test again. Still nothing. I do have a little bit of a theory. So if we go into the web worker code, it does execution context.circuit.on, but I think that the circuit is actually recreated when you execute. So that's actually not going to work. We need to bind the event listeners. Prior to, right after execution. Yeah, it's a little weird. Okay, that's definitely the issue. Okay. We're deep in it now. Web worker, execution context. All right. Oh. Okay. Okay. So we need to track all the events we want to bind. So we'll say event listeners is, it's kind of an interesting signature. Do I want to use that signature? Okay. Seems standard. So we're going to track all of our event listeners. And then whenever we do on, we're going to say we're going to add, we're going to add this to our sort of array of event listeners. And then we should be able to do this. And then whenever we create an execution context, we're going to bind event listeners to the circuit. So we'll make a quick utility function. Yeah, super simple. I don't know why it's, I'm going to be very lazy about that. Okay. So whenever we create an execution context, we bind the event listeners. Simple. Okay, let's try now. Listener is not a function. Let's try that. Yeah, now we're talking. All right, let's do a quick... We could do a snapshot test here, but that would break all the time. Let's just... This is a pretty good test, but let's add a log line just to double check our work. There we go. Nice. All right, now we're getting the events. Tons and tons and tons and tons of events. Perfect. Awesome. So much data. There's also events for... Yeah, there's a couple events we might want to track beyond the one event I have listed there too. I don't know if it's really worth getting too far into it, but oh my gosh. Async effect complete and then async effect started are going to be two really good. But do we just need to export that? Oh my gosh. Okay. Async effect start. Async event end. Those are going to be really useful. I just did a breaking change, unfortunately. I don't know what that's going to break. Async effect complete. Here, end. Nice. Okay. And then let's go ahead and emit the start, and then we can do some tracking on these async effects. So that'll help us track the time to auto route. It's not really for now, that's for later. And then I'm going to do an org-wide code search to see if how much we're breaking with this. So if I do async effect complete, I can see everywhere where that's used, and it's not used anywhere. Yeah, so got very lucky and we're not breaking anything. It's only used internally to core. So queue async effect, I think that's the perfect function to emit a start event. So we'll do this. Async event start. I have no idea why there's so much any casting in here. I don't know why it complains about this here. Property root does not exist. I don't know why it's complaining. Okay. Looks good to me. Refactor async effect event names. Arguably, this should also have the renderable prefix, but I'm going to leave it out. Naming is important. Okay, so this one we're going to say fix event listening. Wow, I am glad I had started this implementation earlier because it just would have been so much mental energy to both implement all these render events, test them, work it through every module. Because I was always kind of thinking about it. It's clearly broken, but I was always kind of thinking about it. So now I can move relatively quickly. And I have an end use case in mind, so that's good too. Okay, so our tests are failing with that change on core. Dirty pattern and async effects. Dirty pattern and async effects. Okay. Fail. The dirty pattern is when you mark something as dirty for the purpose of rendering. That's a common rendering word. Something is dirty if it needs re-render. Undefined is not an object. Oh, interesting. So it seems our type error was actually helpful there. Let's just say, I guess we can do the same thing if root in this. We might need a test to make sure these are working because now I'm kind of skeptical. I don't know why there wouldn't be this. Maybe very early on before a component is sort of attached to the render system. Maybe that's when it can't emit. But it's kind of weird that an async event wouldn't be able to start. That it wouldn't be mounted and it would be doing something. So cautiously pessimistic on how well this actually works. Oh yeah, it's actually just a byproduct of this test. This test is really weird. Probably oversimplified, and it's never actually mounted. Okay. Okay, we got a type check issue in our web worker stuff. Doing 2 PRs at once. Okay. Oh, we already had a test for event forwarding, I guess, but we mounted after execution, which is a little weird. Okay. So let's adjust the event type a little bit here. Yeah, shared types. So instead of doing this, we'll open it up to a couple other event types. So we'll say async effect start, async effect end, and then we'll also say renderable render lifecycle string. So we just kind of let anything go in there. That way we kind of support different render phases. It's not great, but see if that works. It's gonna mess with autocomplete in a weird way, but it's fine. Fixed types. Okay, so we need to merge both of these PRs to really be totally happy, but mainly this one. I'm just gonna, before I open a third, let's make sure that both of these get in. Okay, this one's good to go. Okay. Rename async effect complete to async effect end. Add async effect start. Improve refactor for clarity on emit functions. I don't know. That's basically it. Okay, we'll merge this one too. I'm going to take a brief detour on this while those are publishing, because they have to build and publish in the background. We might have a pull request to open the PCB viewer automatically. Ooh, I don't think it's doing it yet. So it takes a little bit of time, but it wants to auto merge, but it's waiting. So normally I could just merge this, but it's not merging the one I want. I want it to merge the PCB viewer update where we did that big optimization. It looks like version 1.11.6 has it, but Renovate hasn't picked that up yet. So maybe we do it manually. I'd really like to see those changes live though. So I am tempted to do it manually. Yeah. It's using a pretty old version, so it might even be hesitant to update. Oops. Let's try doing it. Okay, maybe not. I'm having some weirdness in the CLI here. Sometimes this happens when you have a lot of remotes. There we go. I'm not going to do it. Doesn't matter. We'll come back to it because we have other things to optimize. Maybe when we finished our little optimization run, we can come back to it. Let's go back to run frame. We'll update the eval web worker. Getting lots of names of obscure modules, but I don't know. I don't know if it can be helped. We got a lot of stuff going on. So we'll want to update to the latest tscircuit/eval web worker. You know, I created a new module today. Sorry, I'm all over the place, but I created a new module today, and I think I can just rename it. It's called like render snippet or something. Render snippet. I think this could just be called eval. I think that's a little bit of a better name, since the other one is eval web worker. Let's just call it eval. want to run this in a background web worker, use tscircuit/eval web worker. Right now, I just use eval web worker for everything because, like, why not? It's a little bit better from a just like, you know, if you can run something in a background thread, you might as well. It also has nice isolation, which I kind of like. All right, we should be getting render events now with our fixes. Yeah, there we go. Okay, now we got all of these render events. And again, this is like for a really simple circuit, so lots of render events. We can record the time we got these because the events don't currently have a timestamp on them. So we can record the time we got these and then use it to figure out how long each render phase took. And then we can throw in a really big circuit and use that to kind of measure what's going on. I think for the render logs, there's a couple things I'd like to do. I'd like to display the last render event because the render events are in serial order. So if we display the last one, we can tell if we got frozen on something. And then the times, like how long did each phase take? How long did we spend in each phase? I think that'd be pretty good. And that'll be our benchmark. But quick bathroom break, and then we'll be back at it. I feel like I've done so many cuts for the stream, but you know, it's like the 2 p.m. stream. Nobody's online. It's perfect. You should be at work, not watching some code live streamer. What are you doing? What are you, crazy? Don't you got stuff to do? I don't know why this camera decides not to track sometimes. I guess it gives up. Maybe if I walk too far away, it gives up now. I wonder if on the whole, if standing or sitting all day is worse. Because now I stand most of the day, but my feet kind of hurt. Like, I don't know. I think it's probably I'd rather my feet hurt than kind of like, I don't know, if I sit for too long, it's kind of like it's almost like a thigh, like lack of blood to the knees kind of situation. I think that's worse. Got to get one of those lumpy mats. You know, I have had so many. Actually, I have one right here. Actually, hell yeah. I'm going to use that. That's a good idea. All right, hold on. Lumpy mat. Somewhat chewed by dog, but lumpy mat. See, this thing has been completely chewed off. But yeah, let's do it. It's a good idea. I forgot about these. You know, it's like the ergonomics things. I always forget which ones I've been doing. Yeah, I forgot about these. I freaking love these things. Oh, it feels so good. I also have a walking treadmill right here. I have a vibrating pad, a walking treadmill, and then I also have a heat pad for feet. The heat pad is the best in the winter. Because I don't know about you guys, but my feet get cold. All right, I'm going to move this treadmill so that I can fully embrace this. Oh, this feels so good. Oh, feels so good. I love this camera zoom. Nonsensical. Absolute nonsense zoom. I love it. It's great. It's absurd. I have tons of cameras now. I'm slowly accumulating different camera setups. I don't know if this will work, but I have a camera mounted right here. Another camera that's kind of cool. Let me see if I can put it on. Oh, I don't know if I can. Oh, I can't. Maybe it's dead. Okay, sorry. A lot of buildup. Now that is exactly what I need. Sitting here literally in a log cabin at my computer all day with a foot of snow outside. It's amazing. And it's like $20 because it's the simplest device, right? It's like coils or whatever. Literally just sucks up your power, turns it into heat. No, it's amazing. It's amazing. Now they got to combine these so that we got this pad, this lumpy pad, along with the heat. That would be amazing. Oh my gosh, this was such a good idea, Space Caboose. I forgot about this thing. Oh my gosh, my feet feel so much better already. Oh, I have another. I just love these little ergonomic devices. I have another one that's kind of fun. So this is a balance board for sitting at a desk. It's a balance board. So you can teeter. It doesn't work well in combination with the lumpy pad. I kind of feel like it's not totally solid, but you can I don't know. This is probably my least favorite of the ergonomic devices. It's the most useless. Yeah, it's kind of the most useless. I got it because I have a tendency, I think this is from playing hockey, but I have a tendency to stand on one foot. And it makes one of my feet really sore. And I can't break this habit of standing on one foot. So I got this teeter board because if you stand on one foot with a teeter board, the board gets messed up. You're off balance. So you have to stand on both feet. And that's why I got it. Okay. What were we doing? Got all the render events. I'm trying to remember the name of the chart for profiling. I think it's called a flame graph. So a flame graph is used for performance when things contain other things. I don't really think that's what we have here. We have something more like a pie chart. Yeah. Because basically each of these are going to... Let's go to our render log type. Let's plan this out a little bit. Yeah, we have these phase timings. That's basically what I'm talking about. How long does each phase take to execute? Yeah. So this is basically a pie chart, but I think what I'm going to do is draw it like a sorted bar chart, because the names are so long it would be hard to put onto a pie chart. So we'll do that. We'll draw a little chart. So every time an event comes in, what I'm going to do is I'm going to do event dot created at and set the time to date.now. Date.now is milliseconds, so it's not very good for performance benchmarking. So we'll switch out of this, but I think some stuff executes so slowly, I think we will be able to detect it. So basically, if it's under a millisecond for that render phase, it's something we do care about it, but like I'm not going to worry about measuring in the microseconds yet. We'll do that later. When the render is getting done, when it's basically done, I think what I want to do is then do the phase timings. So get phase timings from render events, and then we'll pass in the render log.render events. This will probably work, but this is some supremely bad state management because we're mutating things, but we're also using like React, which doesn't, you're not really supposed to mutate things like this. So we'll just see if it works and adjust if necessary. So render logging, we'll say get, what did I call this friggin' function? Get phase timings from render events. I do feel like contributors to TS Circuit, some of them, I do feel like they have gotten a lot better. It's kind of cool, but yeah, I don't know. Yeah, some of them I feel like have gotten a lot better. This is going to be a record of string to number. Okay. So, phase timings is pretty ambiguous, but I think it reflects the total time spent in the phase. So let's add a comment, set this up for AI to generate it. Given a list of render events, return a map of how much time was spent in each render phase. A render event type has looks like this. I'm really struggling to remember. I probably should have done better typing. Oh. Yeah, render lifecycle event, any event. Oh, did I mess up? Created at... I think I messed up. No. We're good. We're good. It goes like this: renderable, render lifecycle, some kind of string, and then start. So that's one type, or the other type is the end. And then we have the created at, and that's all we need to write this function properly. We might need the render ID. So the render ID corresponds to the element that was rendered. For each, to get the time spent in each phase, you have to find the end event for each start event and subtract the created at. Okay, cool. Okay, let's see if we can, if it implements it. Whew. Okay. I don't know if this is 100% good, but because it does this weird thing where it says like, oh, if you don't have a start event, that's fine. It's a little bit weird because like you know, you might have something that's unaccounted for, but shouldn't, I don't know, shouldn't be too big of a deal. We could also do this not all at the end. We could do it as we go, because usually it goes start end, start end, start end. So it's kind of wasteful, actually. They usually come right after each other. You don't have to search the whole array. But it's a little easier to just think about it at the end. But it could be generated as you go, and that would be fine. Yeah, so we'll set the render log one last time. Yeah, all right. Okay, good enough. So let's display the render log dot phase timings now instead of all the events, and see if we get anything. Okay, cool. So yeah, that's basically expected. This one's surprising, 2 milliseconds for that phase, but you know, this is all they're all gonna be small numbers because this isn't hard to render. If we put in a larger thing, it'll be different. But this is pretty good. Let's consolidate everything into the render log viewer. That'll make it a little bit easier to test. So we'll create a new component, render log viewer.tsx. Okay. Okay. And then we want to display these in order of how long they took. So we'll say ordered phase timings. It's going to order based on the key. Cool. And we want to go highest to lowest. So we'll swap that order out. Okay. Display as table. Cool. All right. Not bad. That's actually pretty good. That's gonna get us. That's gonna get us really, really, really far. Yeah, I mean, there's so much we can look into just by knowing how long is spent in each phase. There is one thing I think I'd like to do. First, let's just make this so that it works well with optional. So if not render log, return null. Okay. I'd like to display the last render phase, and that way this can actually be useful while it's rendering. If we just display kind of where it's getting hung up, I think that would be a really good feature. So to do that, what I'm debating is I don't want to. I'm worried about re-rendering the view a lot. So I'm like, I wonder if I could use a forward ref pattern to make it better, or if I should just hope that React automatically solves it for me, because we're just going to be changing like one little snippet of text. So let's say I'm also worried about storing all the render events in memory when there's 100,000. So annoying. I guess the only way to know for sure, let's load in a really hard example and just look at it and see what happens. I could spend forever just wondering, or we could just load in some massive LED matrix and see what happens. So we'll make example 6 or example 7 be large LED matrix. And then we're going to use a cheat code on this one. Because we're allowed to dynamically import, we can actually import dynamically from the snippet's website. We might not do this, like it's not great to not have consistent tests, but since this is like kind of like a storybook sort of thing, it's not that big of a deal. So this is the snippet. So in our main file, instead of doing like circuit.add or whatever, with a board we create, we're going to import. I don't know. Let's just look at the code. Let's try not to run it so we don't crash anything. It looks like it's the default export. So we'll say import LED matrix from tsci/seviibar dot contribution dash board. It's called a contribution board because it's for GitHub contributions. And then we'll do circuit.add LED matrix. And so that should do a very, very difficult render inside of here. That's not it. I had a couple tabs open. Okay, there we go. So it should be trying. We got a weird error here. Yeah. It says manual edits not found. So what's probably happening is I think we haven't tested importing with manual edits enough. So I think it's breaking, but I think we can hot patch it just by adding an object with nothing in it, because it's not even used, but just the fact that the import is there seems to be causing some trouble. So let's try that. I think it's working. So this takes a really, really long time to render, and it's going to take even longer now that we're getting all these things. So we're just going to wait, but it's working down there. It says getting final circuit.js. Okay, there we go. So we have the duration of different events now. And we can see the schematic trace render. This is what I suspected would be the most, was the highest. Source trace render was also very high. And PCB route net islands was also very high. The PCB route net island shouldn't even be executing. So that's crazy how high that one is. Because I think this one is configured to not route at all. If you look at the source code here, it should have routing disabled. Or maybe it has it. Yeah, it has routing disabled. So we've made a couple discoveries here. Schematic trace render takes a while, although that executed pretty quickly. Oh, it's because it's not doing the full matrix. Okay, so even better. Let's increase the size of the matrix. Yeah, okay. I think I understand. Okay. We'll try to do it with the full matrix size. The code doesn't reflect what's actually executing, I think. Just because the way how these things work is you kind of have to successfully build it for the code to be adopted in the published snippet. And it's kind of a limitation. But basically, I just need to get this to run once in the browser. I'm going to hit save, and then we'll start importing the full version and not this kind of partial version. Should work eventually. Nobody's online on the Discord right now. Sad. Okay, cool. We got a render. Let's waste no time. Let's save that guy. Oh, you know what the issue is? I don't think it can save. Payload's too big. Forgot about that. Yeah, there's so many issues to fix just to get this one board to work. Oh, I forgot about that. All right. That is not easily patched. It's funny. It's like so many issues all at once. Just scaling up this board. So the reason it's failing is because of Vercel payload limits. I guess I'm doing this now. I can't do the other thing because I got to do this first. Maybe I'll add the render logs. But I think we only want to do render logs if the view is open for them. So basically, we're only going to do the handling if show render log tab, or not even show render log tab, if default active is render log or something like that. It's not even the default active tab, really. It's more like the current active tab. on active tab change. We'll add an event. We'll track it. It's a little annoying. We'll do it. On value change, set active tab. So it's going right to the state there. See, a lot of people would do this, the pattern that it's suggesting. You should never do a use effect based on a state. Yeah, that's bad practice. So we can refactor this set active tab state, and then we can do set active tab like that. That is a much better pattern. If we use callback, it's pretty good. Yeah, that's how you trigger a bunch of extra re-renders for no reason, by using use effects all over the place. Yeah, we probably need to make this an actual variable. Tab name, or maybe tab ID is a little bit better. Oh, whoops, type. Okay. Okay, now we will track the active tab in run frame. Okay. Okay, it's complaining about the type, which is kind of annoying. So set active tab, tab ID, default, tab ID undefined. I don't know what it's complaining about. Oh, it's because of the void. Yeah, that's kind of annoying. Can fix like that. No? I don't know what's going on. On active tab, blah, blah, blah. String is not assignable. I don't know. I'm annoyed. This should work. Tab ID? Is that it? Yeah, there we go. Okay, cool. So it's a partially controlled. It's not really partially controlled. It's kind of partially controlled because we can set a default, but then it's mostly controlled by the underlying child. Okay, we'll only do this if active tab is render log. So we only compute anything related to the render log if our active tab is the render log. And that way we're not kind of burdening our I'm a little worried about double attaching events too. So that's yet another thing to be concerned about. We might need to make it so you can reset events. I'll create an issue for it. I'm not going to worry about it too much right now. Okay. Let's see if we can test this out. At least make sure we didn't break anything. So doing this, it's going to work. It should show our render logs. That's great because it's the active tab. If we go to some other one and then we go to render log, it's going to be, it's going to display something completely random. Oh, that's, so it's, that's something else. Let's actually say if not render log, no render log, make sure this tab is open when you run the, when you render. Yeah. And like ideally, to do add a re-render button here. We can make this look a little better. Yeah, padding 4, background gray 100. Yeah. All that stupid stuff. Perfect. All right. Okay. Pretty good. Pretty good. This is a self-contained feature, and we don't need to get example 7 working. Okay, so we'll say finish render or add render log tab. I can't remember the full scope of this PR. I think that was it. That went pretty smooth. There were a lot of bugs all over the place, but I think I built off the work of like a couple months and didn't have to deal with too many bugs. So I think it was overall pretty good. Pretty good feature. Tomorrow is Wednesday. I want to get this board ordered by Friday. So we're making pretty good pace. I'm really worried. I read online that I haven't ordered it yet, so there's still time to revise it. But I read online that if you have too many of these strung together, some people were able to get over 1,000 of these strung together. But if you have a lot of them strung together, sometimes the timing can get messed up. So I'm slightly worried about the if the RP2040, the main microcontroller we have driving the LED matrix, if it is going to be able to drive all 371, just because a little inaccuracy might mean that the ending LEDs don't get programmed, or it doesn't program totally consistently. And there's no feedback loop for me to check, so. Okay, add render log tab. So far, so good. Yo, what up, Arn? I built a really big LED matrix board, and we're trying to optimize it. And I made some issues for that KiCad mod converter, but it should be... I think that one's stable enough where contributors can roughly finish it off, make it better. But, yeah, just trying to get this giant keyboard to render. I think the next thing to tackle, since we have render logs now, the next thing I want to do is get this to save with all the LEDs on it. Even if it's slow, I want it to be able to save. So the issue with saving right now is when I save it, Vercel throws an error because the payload is too big. We're not going to move to Pixie. Yeah, when I started this stream, I was like, oh, we got to move to Pixie. We had a completely custom renderer using Canvas. Yeah, no, I mean, okay, so, all right. There's a lot to that. Hi, bro. I'm your new follower. Thanks, King. Thanks for following. You're in for a lot of fun, let me tell you. If you're a new subscriber, yeah. What's coming? It will blow your mind. What was I talking about? So yeah, our rendering is actually pretty fast. But two things about Pixie. One is the way Pixie has like smarter management of re-rendering entities. Okay, so because of that, they can be quite fast. They can also use WebGL, which is quite fast. So that's why I thought Pixie would be better. But when I started actually benchmarking the code, I found out that there was basically one unmemoized function that was causing all of the rendering issues. And so I memoized that function, and literally with like a 2-line fix, we were able to render up to 1,000 components essentially. So yeah, we don't need it. We don't need Pixie anymore, at least not for a while, because our custom renderer still is kicking. Yeah, I think it might be able to kick for a while. The schematic viewer I'm a little bit worried about. I don't really see a way I can optimize this. The zooming too easily. I think it'll be, I think this one, I don't know. Schematics don't get that big though either. Technically, a schematic with 700 elements should really have like boxes that are hidden, right? Like you don't care. This LED matrix only has one input up here, and it has no output. It just has one input, and then it has ground and power. So it should really just be a box with 3 pins. I want to learn programming. What language should I use for the beginning? I mean, I would recommend TypeScript, but a lot of people use Python, and Python's fine. But I would recommend TypeScript because the sooner you get good at, I mean, I don't know. TypeScript is good. TypeScript has a little bit of everything for everyone. Python, I don't know. So we did make some pretty interesting discoveries, even through doing a partial render of this board around what we can optimize in the rendering process. Because when we look at the render logs, some of these things like PCB route net islands shouldn't even be executing because the routing is disabled. So there's some issues there. Schematic trace render, I understand why that's big. Drawing all these lines is quite expensive. Although I don't actually see that many lines, so I'm guessing it's not drawing quite as many as it's supposed to. But these lines are more expensive than I'd like to draw. So I want to cap how long the algorithm is allowed to spend trying to draw a line before it gives up and does a net label, which is one of these things. So yeah, there's a whole list of fixes, and this one I have no idea why that one would be slow. Create nets from props, no idea why that would be slow. So a lot of very interesting insights from benchmarking. Some unexpected, some expected. PCB route net islands should not be big. A net island is when you have like an isolated series of traces. So like that's an island, and you want to connect your islands together. And you use an adjacency matrix to do that. Adjacency matrix. Yeah. So, which repo contains the renderer code? Yeah. The PCB viewer. I actually talked about it at the beginning of the stream, so that might be an interesting introduction to the PCB viewer code. If you go to the beginning of the stream and just look at me talk about it, I kind of go over it while I'm talking about, how could we optimize it? But there's this thing, the canvas primitives render. So we convert everything into primitive shapes, and then we draw it to this canvas. And then there's this draw primitives function. So it's very simple, and we re-render the whole thing every time. So that's where something like Pixie can do it a lot more intelligently, especially with WebGL. But that's the PCB viewer. But there's so many renderers for TS Circuit. You have the schematic renderer, and then you also have we actually use these functions in our circuit to SVG repo. Those are really, really important because the SVGs we use for snapshot testing, while there's no image at the top of this. But this is probably one of our best ideas / best projects. Yeah. TS Circuit is really crazy. I would love to do like a history breakdown of how TS Circuit was developed, but we were so screwed at the beginning. And by we, I mean I, because it was just me at the time. But like 7 months ago, it was so hard to test things because there wasn't any output format or any way to visualize what you were doing or anything. And so I was like doing a resistor capacitor chip circuit for the longest time and just iterating and trying to get a feel for where things were. And I built so many renderers to help visualize. Then finally, we got to a point where some of the foundation was stable enough to build circuit to SVG. Our standard was extensive enough to build circuit to SVG. So we built that, and that took a long time to get that working and rendering PCBs and schematics well. And then we rewrote the foundation that we used to build this and built a better foundation with circuit to SVG. So it's really crazy the shifting, how many times stuff has been rewritten just because there was no foundation, so we built a crappy foundation. It kind of reminds me of like the Rust people or the Go people. I think the Go compiler is built on Go now. I can't totally remember. But basically when you're bootstrapping a language, you have to build a compiler in a different language, and then you eventually, when your language is mature enough, you rewrite your compiler in your own language. And it was definitely a case of that with TS Circuit, but we do that dance all the time. Basically, every time we enter a new rendering space, we kind of have to do this dance. Yeah, pretty intense stuff. I don't know why I went on that rant, but thank you for staying with me for the rant. All right, so what do we want to do next? There's so much stuff to do. I think getting this saved is a pretty good area. Let me draw some stuff. This is what I find so daunting about projects that have such vast scope. Absolutely. Absolutely. Yeah. Yeah, I mean, the hardest things are the things most worth doing. So there's that. But also it's like, gosh, darn it. It's so hard. Yeah. All right. So anyway, we did this. We did this. Add logging events. We did this. Figure out why it takes so long to render. I'd even say we did this. CLI saving to cloud. This is how I was going to fix the fact that it couldn't save. Kind of impressed, though. I really did not expect to get this done. This week, I want to order this board. In order to render this board, we have to get so many things working. The auto router needs to be able to process the 3,000 traces. That is the most complex thing we've ever sent to the auto router. And right now, because of Vercel, it can't even take the payload. So, yeah. But we got to do that. Yeah, fix the rendering phases. We've got this benchmark that shows there's all these slow phases. So fix the slow phases. Because right now it's like crashing the browser every time you render. That's just difficult to work with. So optimize slow phases. We'll do a little arrow. Okay, interesting choice for the arrow to stop at the border. Excalidraw. Oh, Excalidraw doesn't want to do it. I previously tried and failed to create a Figma for video company, and just building the editor was the most insane thing I ever tried to do. Absolutely. Absolutely. Hey, but you tried a hard thing. That's what matters. But absolutely. Yeah. Yeah. The thing with a project like this is you run into a problem and you realize that an entire startup could be just that little problem you ran into. In my case, like the auto router could be an entire startup. And it is. Like Quilter AI is an entire startup dedicated to auto routing and also layout, but basically auto routing. That is all they do right now. And they have 20 million or something in funding, so they're ridiculously funded, and that's all they do. But like for Figma for video, you could have an entire startup that's just processing video files. Like it doesn't do editing at all. It just converts, a format, and that could be a startup, right? So there's so many. Yeah, hard thing about hard things, right? I've never read that book, Hard Thing About Hard Things, but that is supposedly a book. I don't know what the thesis is, but this is a book by a very famous investor called Ben Horowitz. I should read this. Hard Things About Hard Things. What is it about? What do we learn? Seems like a book for CEOs to kind of like manage their emotions. Yeah. It is pretty important. I am currently reading The Dream Machine after not having read a book in a while and really enjoying it. The Dream Machine. Let me take a look. The Dream Machine. The man who instigated the work that led to the internet and shifted our understanding of what computers could be. I love how they never name the guy. JCR wait. The vision of JCR Licklider. I mean, I like this kind of book. I'm currently reading Chip War. I like the early history of computers. It's pretty cool. I mean, it just feels relatable because it's kind of recent history. So you're like, oh man, if I was designing this chip, and like, oh man, they were optimizing the hell out of processes. It was a cool time to be alive for sure. Okay, optimize slow phases. Yeah, get saving to work on snippets for large files. It's probably the biggest thing. I'm just debating how I want to do this. Let's get the saving to work. I have a hack that'll work. I have two. There's a not hacky way to do it, and there's a hacky way to do it. I think I'm gonna do it the hacky way. But basically, Vercel is saying our payload is too big. So what if we didn't send it the full payload? What if we sent it just the TS circuit code and it ran its execution on server? That would probably work. So that's a pretty good way to do it. But that requires that the server executes code, which really complicates things. And also we have to worry about isolation and stuff like that. So my hack is to use an alternate server that doesn't run through Vercel, which I never deploy strictly to Vercel except for front-end projects if it's a major API service, because Vercel goes down and there's various reasons. So I think I have an alternate server that I can use that's deployed on Fly. So let me see if I can find that alternate server. I got to log in. I like the subject as well. Do you maintain Goodreads or something? I'm interested in what books you have on your list. I don't, but that's a pretty good idea. I'll make a note of that. Book list. There's one book that I recommend a lot, but it's not so much an interesting book, but I really it's more of a like just how do you describe it? It's like a work book and more of a reference book, but I love this book, SQL Anti-Patterns. But this is obviously technical text. I also liked, like on the fiction side, historical fiction. There's this book about this guy who went to Japan, Shogun. Yeah, they just made this into a Netflix, or I think it's a Netflix series. No, FX. But anyway, I really liked this book. I read the book before I watched the movie or the show. The show's great. The book's great. It's all great. And then you can follow that up with Musashi if you really like all that cool Japanese history during the Edo period and whatnot, which I think is pretty interesting. Yeah, there's probably some other books as well, but those two come to mind. Did I merge this? Yeah. All right. We're merged up. Noted. Thank you for the technical reference book. I do that SQL Anti-Patterns book really changed the way I thought about, like, not just database design, but a lot of just like general architecture. That's why I like it so much. It was very influential on my coding style, more so than any other programming book I had ever read. But yeah, very, very technical. Very technical. Also gives you really good names for things. You know, I started using the word polymorphic foreign keys a lot after that book, because polymorphic foreign keys are like the worst thing you could ever do to a database. They are very painful to deal with. Okay, so we do have an alternate URL that doesn't go through Vercel that we should be able to submit large payloads to. So we're gonna hook up that URL, because I can't think of another way to do this. I mean, how else do you upload? How do you upload it? Let's see what ChatGPT says. How do you upload a large file to Vercel over 5 megabytes? Or a large, let's say, payload. So we could stream it. That sucks though. I am kind of tempted to use like an intermediary CDN. S3 has an API where you can a user can upload a file, and then you can just give a link to that file in kind of subsequent steps. So that's a nice way to do it. But man, that's a lot of effort. Especially because this is all kind of temporary. I don't expect the user to be uploading these massive JSON files for the long term. The other thing we could do is, of course, compress the JSON itself. So many choices. What do I want to do? What do I want to do? Upload chunking, or hack it, or do it the right way, but then have to deal with all the security issues. I don't know. I'm going to mull it over. I'm going to go to the bathroom. I'll mull it over while I'm in the loo, as they say in, I don't know, France. I'm team upload directly to S3 and get a link. I love SQL anti-patterns. It's a great book. Upload to S3 directly and get a link. Yeah, you're not wrong. That's a good idea. Okay. Ay, ay, ay. Oops. Just rolled over my foot. You ever do that? Oh, the pain. All right. So S3 upload with link. Ostensibly, that is the right way to do it. What else do we have? Use alternate server. Non-Vercel. Vercel, what if you just let me increase the limit? Because I think we're pretty close. I think it's very close to being within the acceptable range. I didn't know you could increase Vercel functions that much. That's pretty cool. Okay. I don't think Vercel will let us do it. Vercel increase max payload size. Oh, I really don't want to do... Yeah, they literally recommend uploading to like AWS or S3 or whatever. Don't make me do it. The reason I don't like it is because it complicates testing. I gotta like, there's so many more ways things can go wrong if I do it like this. Okay. Let me just take a look at the S3 API. It's kind of a complicated API. I want a JavaScript S3 implementation for my local test fixtures. So JavaScript, what is an NPM module with a JavaScript S3. Excuse me. I'm gonna add with signed URLs too, because I think we might not actually need no, not a client, a server. JavaScript S3 server implementation. They'll make me feel better if I can do testing. Minio. S3 compatible. Okay. Can be integrated into your application. That's exactly what I want. Fake S3. Nice. That's what I like. That's what I like. Also, if people didn't know, I don't use AWS. Not really. Actually, I have a couple AWS servers I need to shut down. I'm going to make a note. I got to remember to do that. It costs me like $40 a month. But anyway, you'll have to spin up a Minio instance. I'll spin it up dynamically. Or can I spin it up dynamically? Maybe I can't spin it up dynamically. You're right. I don't want to have to run I don't want to run anything stateful. I don't mind in my test suite running something stateful. Like, it wouldn't be a big deal for the test suite. But everything, I have a rule. Everything has to run locally for any server. Not allowed to use third-party services, except for so for something like Stripe, yes, you can use third-party services or whatever, but you have to have a fake version that works locally so that everything is testable locally. Which for something like Stripe can take a lot of time to build the fake version. It's like an entire software project, but it's reusable and it's not that bad. So, okay, all that being said, do I really want to implement the S3 stuff? Because it's just going to take a while. I never break this rule. Everything has to run locally. It makes all my projects amazing to work with. I don't even know if this is a server. It kind of sounds like it might be a server. Or they have a server implementation. Can you describe the S3 API? I haven't actually looked at it. I think it's really simple. Like it gets complicated, but I think the core REST API isn't too bad. I own the Stripe integration at work and writing tests for it at the moment. I hate it with a passion. I wish I made a fake server implementation instead of a million fixtures. Yeah. We built at a Seam, my last company, we spent a long time building a fake version of Stripe. I wanted to release it as open source, but we never did. I actually am kind of blown away we never released it. Let me see if I can find it, if it is released. Yeah, but it was something that anybody could drop in. It was like it ran a server if you wanted it to. It would run a full server, and you would just swap out your endpoint. We did that for every third-party service, and it was amazing. Do I know people there still? Yes. Please ask them to release it. You know, I would love it if they did. But yeah, I'm not sure. I'm not sure. Yeah, I mean, if you're watching, if anybody from Steam is watching, sometimes they like the tweets or whatever. That'd be pretty cool to release that. I don't know though. I don't know what's going on at that company right now because so many people left after I got the boot. That it's kind of, I don't know what's going on. Like, yeah, some organizational politics and whatnot. I don't know if they have open source strategy still. But release it, please. I know the guy who worked on it is no longer there, I think. So that's why I'm like, I don't think anybody feels enough ownership probably to get it done. So that guy left. Anyway, I don't know. Yeah, so the S3 API is pretty simple. So we could like kind of implement just the endpoints we need. Or try to boot up a serverless kind of S3 client. A lot of people do that. How did it work exactly? Maybe I should do an open source version now. I have a repo called fake template. Oh, on TS Circuit. I think it's called fake template. Yeah, we build fakes for tons of stuff. Yeah, template API fake. So we use this whenever we're creating an API project. But yeah, the README kind of sucks. So it might not actually be that good to copy. But actually you can look at Seam's fake because they release an official fake for the Seam API. So that's probably a decent one to look at. Fake. Yeah, they have a template too. Fake device DB, fake Seam Connect. Yeah, fake Seam Connect. So this is a fake for Seam's API. Fake Seam Connect. And I think the cool thing about this, let me see. Do you have to authenticate? I think you have to authenticate. But they run a ton of instances of this because it's so lightweight, because it's all just fake in-memory data. If we go into lib, database, schema, there's basically like they've modeled the entire Seam application, like the whole thing here. They have seed data. Everything is modeled here. So you can like play with the Seam API just with this. So that's an application pattern we use internally, but that one is definitely open sourced and quite extensive because it's used for testing all over the place. Yeah, so these are basically all the S3 endpoints. I don't know. I don't know if I want to bother with this. It's going to take so long. Let me open up the project. I think what I want to do, there's I used to call this survival mode. Like or I would ask people, what would you do in survival mode? So you need to get something done as quick as possible because it's existentially important for the business. And if you just like, you shouldn't always do you shouldn't always pretend you're in an existential crisis, but it's a useful thought exercise because sometimes it points to like the simplest solution. Feels like a bad solution though. If you're test against your implementation, you won't know if something's wrong until you release to prod. Yeah. So what I like to say is that the upfront capital of the fake is extremely high because of what you're talking about. You basically have to mimic all this production functionality. Yeah, your own fake implementation. Yeah. I have implemented personally like at least 30 third-party API fakes. Like personally, I like end-to-end have written like a fake for a third-party API because the pattern is really useful. But what you do is, you find a bug on production, just like you're finding bugs on production with anything else, and then you incorporate it into the fake. And you just keep doing that over and over again until eventually your fake gets pretty good at mimicking production. But yeah, like anything else, you're going to have production bugs. And it sucks to have production bugs with something like billing, but you get really good at making fakes. I think I have a blog post on this too. Fast outside-in testing with Postgres. This combines several concepts, but one of the concepts is using fakes. And yeah, I even use Stripe as the example because Stripe is so good. People think that you should use Stripe test mode in testing, but you should not. It's not. It's not nearly as good as a fake. Plus, with a fake, you can like turn on. You can like turn on different modes. You can say like, oh, the Stripe API is down, and let's simulate that. And you can simulate that in different states. You can like turn on all these different little modes, and you can't do that with the Stripe API. You can't say like, oh, I have a legacy customer with data that you can no longer input into Stripe. Yeah. Fakes are the most controversial and yet the thing I feel most strongly about. All right, so our registry API alternate that runs on Fly does seem to work. So I have a URL for that. So what I'm going to do is I'm going to implement that. It's going to send it to the non-Vercel API. I'm just going to do it because I think that's what I would do in survival mode. And it's very daunting for me right now to implement S3 because of that fake requirement. Although I would do it. And honestly, AI can write fakes really quickly. So it probably would only take me about 3 hours, maybe a little bit less to get the fake working. But I would also like, I don't know. I just don't like the idea of having to set up external services right now. I like to have one external service, just Postgres, for as long as possible. Yeah. Anyway, a little bit of a rant. I'm just thinking out loud. Okay. It's good questions though, Arn. Appreciate it. It's good thoughts, you know. Clearly a seasoned developer. It's good to have you. Okay, so where do we save the snippet? I'm trying to think of the URL to save. It's probably snippet/update, if I had to guess. Okay, so there's a couple places where we're updating the snippet, evidently. Update snippet mutation code in preview. And then we have editor nav. We're also updating here. So we'll probably want to consolidate this a little bit. Although this one, it's only updating snippet type, so we don't need the alternate URL here. Rename. Oh, yeah, it says it right here. Editor nav. So that's for changing the type. That's handle change type, rename, use save snippet. So what I want to do is basically do a try catch. This is kind of weird. It feels like there's a duplicate implementation. Update snippet mutation and then use save snippet. It's like a duplicate implementation. I wonder if that's why we sometimes have snippets that are saved kind of inconsistently. I feel like I've been sighing a lot today, but this is pretty drudge. This is a lot of drudgery. All right, let's split. Come on, VS Code. Fucking hell, split the tab. Come on, why? How does this work? There we go. All right. What's the difference between these implementations? Is there any major difference? This one checks the compile result. This is so confusing. Save snippet. Where is this? Oh, okay. This one is only used on the AI page, which nobody uses right now. So I'm gonna ignore it. So we can just focus on this one. So what we're gonna do, I'm gonna save this payload into a variable, update snippet payload. This is terrible. Parse JSON or null. How does that validate anything? It returns null. This does nothing. Chesterton's fence and all that, but nah, F that noise. I don't think that does anything. You guys know what that is? Chesterton's fence. Ever heard of that? Chesterton's fence. It's when there's a fence in the middle of nowhere, and you wonder why, so you remove it, and then it turns out it was really important. A logic problem to justify the need for A/B testing. I don't know about that. I don't know about that. It blows my mind that Twitter and Twitch and whoever, YouTube, are willing to store these like movie length streams of me just coding. You know what I mean? Like at some point I don't know, I guess storage gets cheaper all the time, so it's probably not that expensive, but it's like I basically upload 3 movies a day and they're just cool with it. They're like, "Oh yeah, that's great. That's what we want." I guess we're in an era of abundance when it comes to data. Okay, so this Axios post thing, we're going to try this. And then we're going to throw... This is also unnecessary. Unless this Axios instance is special. Yeah, I don't... Man, I don't know if AI wrote this code or what. I used to have a blame tool. Do I still have it? I don't think... Oh, yeah, I do have a blame tool. So I can see at the bottom who to blame. So maybe we can blame somebody. But that's completely useless. Like, Axios does not... Chesterton's fence all over here. It says it was me. I don't know. Must have been AI. But Axios throws anything that's not 200. So completely useless to do that. And it's a shitty error. It's way shittier, that error. It was like, oh, failed to save. Okay, so if this Axios error throws, and if the error contains... this is where things are going to get tough. Okay, so if error is was it 429? Then don't throw. How do I figure out if this is an Axios error? Check if an Axios error before checking for the 429. See if it can fix this for us. Yeah, Axios is Axios error. Let's make the subsequent request right in here, because I think that's a little bit more clear. I don't like nested try catches. I think they're really annoying, but I don't see a better way. It's my Vite machine. All right, they recommend just checking for error.response. I'm going to do that. Error.response.status. Fair enough. Fine. So we'll do anycast. We're not going to have types on this. Error.response. And error.response.status equals 429. I also need to check for cell 429 error. Is that the right one? Function rate limit. No, that's not the right one. Oh, it takes so long to test this because the payload has to be so big. Vercel error code payload to large. 413. That's right. Okay, so if we get that, we're going to try again. But we're going to do a post to alternate registry URL is what we'll call it for now. I don't even think that's how you use environment variables in Vite. I think it's like import.meta.env. Yeah. Vite is weird. Oh my gosh, this is gonna be so friggin' annoying to test. Okay, where do we define these? So Vite alternate registry URL. I don't know. I think I just need to add it inside Vercel, I'm guessing, in the build environment. Avoid Vercel is what I'll call my branch. Re-request to non-Vercel URL for large payloads. This is a temporary problem. The large payloads will eventually go away. But if they don't, we'll use S3 in the future. Or some janky version of S3 that we come up with because I want to avoid AWS. I heard there's some pretty popular alternatives. There's R2, that's an alternative to S3. I think there's a couple other ones. Vercel was very like freedom of speech for a while, and people got upset about it. But everyone seems cool with it now. I don't know. Let's configure our snippets app with our alternate URL. So we go to settings, environment, try not to reveal every environment variable, Vite alternate registry URL, paste that in. Okay. So I don't know, hopefully that works. I don't know if I just YOLO merge this because it's so hard to test, but like I know I'll regret it. I always regret not like doing thorough testing. It's not going to break anything, but it is annoying to test because there's only one server running. Yeah, I don't know. I think I'm going to YOLO it. And yeah, it's not good practice. I'm abusing my admin privileges here, but it would be a good candidate for a preview URL, but our preview URLs are currently a little bit broken in that you can't log in because of a security issue. Because if we let people log in on Vercel preview URLs, I think it creates a lot of problems, security issues. Yeah, I think we can resolve that. Yeah, I don't know. If this fails, I will fix the security issue preventing us from doing Vercel preview URLs. That'll be my compromise. But if it works first try, then I'll just say thank goodness, and I'll roll with it. So the end result of all of this effort is we're going to be able to see the render logs for a really, really big board, because this board didn't take that long to render because it was partial. It only took like, I don't know, maybe 3 seconds to render, 4 seconds. So it didn't take that much time, but the actual board takes like 2 minutes, 3 minutes, maybe a minute. So hopefully, once we're able to save it, we can use it in our local test, because we pull it in for our local test, and be able to see a better breakdown, and then we know exactly what to optimize. We're going to know very, very... I'm sure this isn't representative. A lot of these things grow in difficulty exponentially, particularly the schematic trace render, I think, grows exponentially. So I think we're going to see... we're going to see a major area of improvement. We're going to know exactly what to optimize to fix this thing. Okay, so that's going to take a little while to deploy, but we've set up the URL. Vercel is deploying, so we're just going to wait for a minute. We'll test on prod. I guess while I'm waiting, there's something I've been wanting to do, which is install the Vite plugin for Vercel. So I got a really good song playing. Gotta like it. Oh, I already liked it. Plugins. Yeah, so right now we only have the React plugin. And then we dynamically add some other plugins. Let's see if we can add the Vercel plugin. Import Vercel Vite plugin. No, it's not. I don't think that's it. Vercel Vite plugin. So this might fix an issue with pages loading a little bit slowly, because I think Vercel doesn't know how to read entry points. Yeah, Vite plugin Vercel is what we want. Supposedly this gives us a lot of features. So let's hope for the best. How do I use this? Vite plugin Vercel. Just import Vercel. Okay. All right, that is supposedly it. So let's throw it on a branch. We did it. And where we'll see if this really worked is when we deploy to the preview environment. We should be able to see if the pages are loading snappier. We'll be able to do the lighthouse testing. We should be deployed now. Let's see. Yeah, we should be all deployed now. So let's see if we can save our big board. Okay, we'll go to edit code. We're going to hit run. This is still going to take a while. We haven't fixed the rendering, the circuit rendering, distinct from the PCB rendering. The PCB rendering is fixed, but not the circuit rendering. So we got to wait. It's going to freeze my whole browser tab because it doesn't run in a web worker. Just something people are working on, and I should probably come in and help with it at some point. You guys can't hear it, but I got some absolute jams going in my earbuds right now. I'm not allowed to play copyrighted music. Go, go, go. Oh, I can't wait to be done with the slowness. There's so many areas to optimize. It's crazy. But it's all planned. It's all planned out. Everything will work. Okay, this PCB viewer is still slow, but that's okay. We're not here for that. Save. Oh, I should open up the network panel. Shit. I might have messed up. Did it work? Everything's so slow. Please save. Okay, so we got a 413. There's our 413. It should have tried twice, but it doesn't look like it tried twice. It's possible our logic is wrong. Payload too large. I'm just going to take a screenshot of this because otherwise it's going to be really easy to forget the details. Add it to our little board. Our board of dreams. You guys ever make a checklist? Like you make a daily checklist and it's just super, super, like it's got like everything you could possibly want to do. And you're never going to be able to do it all, but it's comforting to just think you could. All right. I guess I'm a little surprised this didn't work. I'm going to try, I don't know, maybe I don't have the latest version of the code. Could be using a cached version. It sucks I have to wait for this page to render again, but I'm going to give it one more go before I give up. If we give up, what we're going to do is try to test it locally. We have to. You can't skip on local testing for too long. I'll find a way to do it. Maybe I'll add a header or something to make it easier. I'll add a header like second attempt, and then I'll abuse that header just to verify that we're able to get to the logic properly. Since we have a screenshot of the Vercel payload, it should be pretty easy to replicate it and simulate that condition inside of our API fake for snippets. Got to wait for this browser to load though. Go, go, go. You can do it. Let's check on the other PR we did while we wait. Okay, everything seems okay. Let's view the deployment. So if I do Lighthouse scoring on this deployment, it should load faster. That did seem to load faster, but I won't know until I do Lighthouse. That'd be awesome if this just magically was fixed. It's also exactly what I suggested on stream. I don't know if anybody actually attempted this, but if somebody who attempted it is now watching and this works, this is exactly what I suggested. So it's running its Lighthouse tests, generating a report. Oh no, it didn't work. Didn't work. Performance is still garbage. Yeah, it's loading asset bundles it shouldn't be loading. Yeah, these product previews are kind of bad, so we need to serve these in better formats. Yeah, and images aren't properly sized too. Yeah. Hmm. Using multiple Vite entry points with Vercel. I don't know if I'm going to be able to fix this. I don't know what I'm going to do if I can't fix it, though. I could try doing a Vercel monorepo pattern. Maybe I just need to configure the plugin. Oh, it didn't. Oh, this one. Oh, wait a second. Oh, wait. Oh, these are both community plugins. Wait a second. Oh, this one only has 107 stars. What about the other one? Oh. Kind of liking the looks of this. Let's see how many stars it has. Oh, it only has SSR Legacy. Oh, Vike? What? Vike? Oh, never mind. I guess these guys have switched things up. Vike. I bet it's file system routing, which is amazing, plus Vite. Yeah, it's got routing built in. File system routing. I effing knew it. It's a pretty good idea. Vike. How popular is it? I don't want to use something that's not too popular. It's pretty popular. All right, in the meantime, let's figure out how this works. Pre-render config. Okay, so there is configuration required. ISR. What is ISR? ISR and SSG pages are mutually exclusive. ISR prevails. That's infrastructure. I don't know what that is. If ISR, what is ISR? I remember ISR rendering. ISR Vercel. I think it's incremental static regeneration. I think that means it's re-rendered on the server. I think we want SSG for the landing page. Oh my gosh. Does this not have types? Oh my gosh. Are you kidding me? You've got that. No, it's got to have types. We were just looking at types. What the hell is this? Let's do type / Vite plugin Vercel. Oh my gosh, you got to be kidding me. No, you got to have types. Come on. Declare function all plugins. Options any. Maybe I just don't understand the usage. Let's read more. Oh my gosh, what a pain in the ass. You can use Next.js, and then you don't have to deal with any of this. Probably would have. Shoulda, coulda, woulda. Should I just convert it to Next.js? I probably could. That would take so long, though. I like Vite more for local development. Oh man, this is death. This sucks. I like Vite Vite plugins. You can write a quick Vite plugin. You can have AI write a quick Vite plugin that does a like proxy API server. It's friggin' awesome. Simplifies development so much. But then Next.js is better for deployment because it's so baked into Vercel. Vercel does a lot of heavy lifting. I know the Open Next guys are working on making things work, but oh, I see. So it's part of the define config command. So it looks like they extend how you define the config. It's not passed in as a config here. Instead, you go to define config, and then I say Vercel. Let's maybe put it at the end. So we now should be able to say Vercel. Oh, okay. Oh, wait. No, what do you mean? What do you mean? What do you mean? Okay, so promise user config. I don't know. Well, this is unfortunate. Somehow I broke the syntax all over here too. Let's go back. Okay, this is working. I don't know. I guess I'm an idiot. Okay, so we got ISR. We want SSG, I think. Server-side generation. I love it so much, you know. It's my happy place, debugging Vercel deployment configs. Pre-render config. Okay, pre-render. Pre-render. Vite Vercel pre-render function. Okay, so it takes a function. That function takes a resolved config, and it returns a Vite Vercel pre-render route. Is this maybe this thing is popular enough where AI can help me out here, because I'm dying. Can you give an example of Vite plugin Vercel being used for SSG? Now I get why Vite was able to create a whole company. I forget the name of their company. It's like 0 something. But oh, that's definitely not it, right? SSR static true. That's too simple. That'd be amazing if that worked. SSR. No, it's not a thing. SSR. It's not there. It doesn't know. If present, this function is responsible to create static files in .vercel.output/static. So the function has to create the files? What kind of config is that? You're like asking me to build a bundler. This is terrible. Wow, that's terrible. Yeah, don't use Vite for deployments where you're going to have some sensitive page loads. I'm like debating like making it so that we deploy via Next and then develop with Vite. That's terrible. Wow. I get why there's so many startups playing in the space because yeah, Vercel really took the torch and broke it. I could try giving AI a bunch of documentation because it can probably read this a little bit better than me. Here's a Vite Vercel config. Please configure it so that the landing page loads is SSG rendered and rendered separately than the other pages. I'm just going to give it like everything. All the data I have. I'm going to use O1 too. I'm going to throw everything I got at this. We'll give it the Vite config. We'll give it our Vercel.json. Okay. See what it can do. We were rendering this in the background. It looks like it finished. Let's try saving again. And we're going to watch the API requests. So we should get a 413 and then a 200. Oh, that's a pre-flight. That's a pre-flight. It doesn't work. It doesn't work. Yeah, it doesn't work. Okay. I don't know. Let's finish this thread with Vite and SSG. Okay. We basically rewrote this file, so I'm just scanning for things that actually changed. I don't see what it actually changed. Plugins, visualizer. It almost looks like it stopped short. Vercel config. Oh, no, there it is. Oh, it's saying that pre-render just needs to... Oh, I think I get it. So pre-render is just giving the props. That's actually not bad. It's not a bad API. Okay. I don't know why the plugin would need that. I think this is fine. Okay, cool. Let's see if that works. I'm just going to manually do a preview deployment. We'll test that out. I am not sure why this guy saves here. I think I need to add some logging. I should have done it the first time. Yeah. Failed to update snippet. Because then we could figure out if we should be reading like the error.status or something like that. I'm not 100% sure. Yeah, because there might be an error.status object. It's unfortunate. It it could also be true that this isn't defined. I don't really want to do prod debugging though. Yeah. Yeah, I'm not sure. All right, well, there's a lot of work to do here, but we're coming up on 3.5 hours. It's about dinner time, so it's probably a good ending point, I guess. The most interesting thing that might happen in the next 30 minutes, if I'm really lucky, is we get to see the performance benchmark on this. But I don't know if we'll be able to fix it. We'll just know what to fix, and we can take a look, investigate it. But I think it would take over half an hour to get there. So probably a good time to cut it off. Thanks for joining. And we'll keep it up. Hopefully we get to order this board this week and write some firmware for it. I think it'll be fun.